Hello, Foundation students. So I wanted to talk about your Project Components 101 assignment that's due and discuss the multimeter, and we can understand how to use it and how to use it for a diode or an LED. I'm going to share my screen to my doc cam. Let's get rid of that. Let's share this. And we should be able to see the screen right now. So what we have here is a multimeter. So I'll unplug these for the moment. And the multimeter has a bunch of different places around it, different knobs that you can turn it to. And each position measures a different thing with a certain level of accuracy. So if I were to be on these blue areas, for example, we see that there's a V here. That V is related to volts or voltage. If we were to go to this white area here, we have an A, which is for amperes. And that's our current. And then the last area down here is this capital Greek letter omega, which stands for ohms, which is resistance. So depending on which one of these you are turned to, that'll tell you the value, the maximum value you're able to measure. So for example, we're going to measure the resistance of a resistor. This has nothing to do with your assignment. This resistor is 220 ohms. I know that already. So what that means is if I were to do this to 200, 220 is greater than 200, we will end up seeing an overload because we are over that value. So let's try that. So let's turn it to 200. We can see right now there is no resistance. It's overloaded because there's nothing plugged in. So what I'm going to do is I will take, somebody's knocking on my door. Give me 2 seconds. Okay, sorry about that. So if we turn it to 200, we see that there's nothing showing right now. This 1 means it's essentially overloaded. So what I'm going to do is I'm going to take my black pin prong from my probes, and I'll plug that into ground. We can see that the symbol here is ground, and we see that it connects perfectly to there. And I will take my red probe and plug it into the one right above it. And you do not have these in your kit. I have these fancy alligator ones, which are easier to grip. So I'm going to do that just for example base. So if I grab the probe, or grab the resistor with my probes, we will see that it shows a 1 because it's too big. If I switch it to the next one over, which is 2000, we can see now that wow, that's exactly 220, which is pretty incredible, honestly. There's some inaccuracies. That's pretty cool. Now we are able to measure it because our maximum is 2000. If we keep switching, we could see that we end up with a smaller resolution. This is in units of 20 kiloohms or kiloohms. It becomes a little bit harder to read. And every time we go up in value, we end up with more inaccuracy because of the fact we have a greater span of resistances to look at. So for our purposes, we want to be as close as possible and be slightly above it to give us the most accurate answer, which is roughly 217, 220. And that's what we see here. So depending on what we're trying to do, we can use this to measure different things. Now, the thing that you need to use for your project components is this concept of the diode, the LED. Before we talk about the LED, I want to mention continuity, which is the other purpose of this knob. This is the little audible sound wave that's here. So basically, if you have two things that are completely connected together without any sort of resistance, it'll beep. And that beeping basically tells us that these are electrically connected. If I were to do this with the resistor, this resistance is pretty small. It might work, but nah, it's too big. So you can see that even though I'm connected, it is measuring resistance. You can see that on the screen, but it's not beeping because they're not shorted together. There is a substantial resistance in between. If I were to use a normal wire without any sort of resistance, what you would see is that it would beep. So let's go ahead and I'll grab a wire real quick. And I already did this in class, but I'll do it again. This is a normal wire. That one has resistance. That does not have 220 ohms. That was bad placement. But if I go ahead and I prong both of these, it's beeping because of the fact that there's no resistance in between. It's very small resistance. It's shorted together. Again, if I do this one, because there is resistance in between, it won't beep because of the fact that the resistor is present. So that's what continuity means. If something is perfectly electrically conductive, it'll beep to tell us, hey, these two are conducted together. The other purpose of this is to go ahead and measure the turn-on voltage for a diode. So the symbol of a diode looks a lot like this triangle here, where we have a wire, you have a triangle, and then they do the symbol to say that there's a wall there. And the general idea is that you'll have current flow in this direction, in the direction the arrow is pointing. This wall is here to illustrate that if I try to flow current in the other direction, this wall stops it. So current cannot flow the other way. That's not possible. I'm only able to travel from left to right based on this drawing. Now, due to the way that these are made, the voltage between here and here has to be some value in order to have current to flow. So you need sufficient voltage to allow current to flow. And that is what we call our turn-on voltage of the diode. And that's what we're trying to measure, this turn-on voltage. So this is a type of diode here. In your kit, they're colored, and they look like these little spaceship things, where you see that one leg is longer than the other. That this leg is longer than that one. This leg is longer than that one. And in general, this leg here, the longer one, corresponds with the input of the circuit. So current will flow up the long one and then out of the small one. So again, this is the long leg. This is the short leg. So the way that we can do this is that we'll take our input, which is the red one. That's the input. The black is the receiving end of it, which is the ground. That's the end of our circuit. The start of our circuit's in red. And I will attach that to the long leg. And then I'll attach the other guy to the small leg. It's also kind of hard to see. It is lighting up. And you can see that this turn-on voltage is showing 1.854 volts based on the screen. So what that tells us is that the turn-on voltage is 1.854 volts. So you need at least this voltage across the diode for current to flow. And once current flows, that lights up. So assuming that we have more than this, that'll turn our diode on. And that's essentially what we are testing for this video, for your homework. Now, you do not have these, and it's a little bit more difficult with your prongs. So there is a way to do this with your breadboard if you find that to be easier. So we can go ahead and try that right now. So here's our breadboard. We can ignore the Arduino. We can ignore that. And what we talked about in class is that these columns are all at the same value, and then these rows are all at the same value. Note that there's a big break in between here, basically giving us two different sides of the breadboard to work with. So these rows are not the same as these rows. This line here separates it. Remember, there's physical metal underneath here that's connecting these pins together. That metal does not run across this gap. The metal is here for these 5 pins, these 5 pins, these 5 pins, etc. And this long column, that's 25 pins. So let's say, if you don't like to work with this, let's say that I will have the positive part or the input to our circuit, into the positive pin, which means that everything along here is positive. And what I want to do is ultimately connect that positive to the long leg of the diode. So I can grab another wire, let's say, and I can bring it from there to really anywhere on the board. It doesn't matter because it's kind of arbitrary. But the important thing is that because this pin is filled and it's along the same column, whatever we're bringing in from the red will reach and be transferred over to this row 14. Because this blue sees the same thing as red, that blue is going to transmit it to here. So now 14 has the exact same value as the positive terminal. So next thing is that we want to attach the positive lead to our diode into that. Grab a diode because that one did not like light up like I wanted it to. I'll grab this diode. So this is going to be the positive terminal. Here's our long leg. Our long leg is this one. I'm going to take that one. You can see it. That's our long leg at the bottom. I'm going to take that and plug it into that same column and then, or that same row. If we look up close, we can see that 14, that has the long leg in it. That goes up and that goes to a different spot inside our breadboard. That's row 13. And now we want that to be brought back to ground. So what I can do is I can just take any spot in row 13 because they're all at the same place. And I will bring that to the negative part of my circuit. Like that. Not sure that's perfectly in. Let me get a different wire just to be safe. And again, it doesn't matter where it goes. I'm just going to make sure it's in the negative column. I think that works. So what do we have here? Let me draw this on paper. Oops. So the positive will ultimately be my input. That would be my DMM, but I'll just draw it as a voltage source. That is going to go to here. So let's say that this is my red wire. Red wire's here. Now we have our blue wire, which is this. That's going to go to row 14. And then that's going to go into my diode. So this is row 14. Once you go through the diode, now that is row 13, 14 to 13, 14 to 13. And that 13 is going to be ultimately connected to ground, which is going from 13 to the negative terminal. So we've completed our loop. Well, sort of, because we have to actually attach this to ground. So I would just include an extra wire here. Now let me do white. An extra wire here. Now I have a circuit complete. So if we were to take our probes, if you find this easier, you can take these down or something. And what I'll do is I will attach, oops, that's black. Red is always hot. We'll go ahead and attach those. Now if I turn that to the multimeter, you can see that it's on now. And if we come over here, we see that our turn on voltage is around 1.943 volts roughly. So this is another way of doing this. This is more complicated. This is good practice to understand how this works. But in general, you could do it just by attaching it directly to here. Either way is acceptable. It's your preference, depending on how you want to wire things. The first way is easier. This way is a little bit harder, but this will teach you a lot in the process. So I recommend doing this way for learning purposes and for engineering purposes, but either way is fine. Okay, I hope that this makes sense. If it didn't, please reach out to myself or the TAs. Okay. Thanks, guys.